All right, on the back side here, there's only 2 questions, and it says, let's see, for each of the following questions, write an equation, write an equation, not and. See, I told you there's typos in these books. Write an equation, complete the table, and graph the data for the following problems. And I like to insert what's called an Oxford comma here too. Anyway, 2 times a number increased by 5 is equal to a new number. Blah. I love these things, don't you? Okay, here's what this is saying. Listen, okay, we don't know what this number is, and we don't know what this new number is. It just tells us a relationship, though. It's like that magic trick, right? Think of a number, any number. Think of a number, any number. Okay. Now do 2 times that number. Got it? Now increase what you're thinking of now by 5. You should now be thinking of a new number, one that's different from the one you started off with. Okay? That's what we're doing here. We're just doing like this magic trick. I can't actually read your mind. I have no idea what it is. But let's say this person started off with -2, right? Think of a number. Okay, I got -2. All right, do 2 times of that. All right, -2 times 2 is -4. Okay, now add 5. -4 plus 5 is 1. Your new number is 1. See that? Let's try again. All right, now you do this. I'm not going to even say what it is. I'm going to say, okay, ready? Think of the number -1. Got it? Now do 2 times that. Got it? Add 5. Okay, what do you got? I should have done it. I don't know what it is. 3, right? I think it's 3. Is it 3? Oh my goodness, I should have done it, right? Yeah, it's 3. It's 3. Okay. All right. Try it with 0. 0 times a number. I'm sorry, 0 times 2. Add 5. Okay. 1 times 2. Add 5. 2 times 2. Add 5. Okay. That's what we get. Now check this out. We could write this algebraically. I could say, in order to get your new number, you're going to take your old number. You're going to multiply it times 2. And then you're going to add 5. Isn't that what we did? Think of a number, multiply by 2, add 5. That gets you a new number. Okay. Now this is kind of cool. Actually, let's graph it first, and then I'll say what's cool about this. All right, so your graph looks like this. So I'm going to plot these points. -2, 1. And again, you can pause the video, do it yourself, then come back and check if you would like to. Let's see, -1, 3, 0, 5, 1, 7, and 2, 9. If you connect your dots, you should get this nice, beautiful line that looks something similar to what Mr. Baker has here on his page. All right? Okay, this is the cool thing. Check this out. I could have gotten this from, well, let me show you how this relates to the table. This is really cool, all right? This number 2 that's in front of your x is your pattern that's changing here. So every time you're adding, what number? You're adding 2 every time. That number goes in front of your x. This number 5 is called your y-intercept, or your initial value. It's the value when x equals 0. When x equals 0, it's 5. Cool, right? Visually, it looks like right here. This number 2 is your slope, again, you get in 8th grade, is how many numbers you have to go up before you can go over 1. That's that number 2, all right? So to get from one point to the next, I have to go up 2 before I can go over 1. That's where that 2 comes from. This number 5 is found on your graph because that is the point at which your line goes through your y-intercept. It's right there. That's where it crosses. They meet right at 5. All right? I said it was cool. That's 4.5 minutes. We'll stop there.